Okay, so as you know, we're doing everything we can for the sake of COVID, right? And since we're trying to do everything we can for the sake of COVID, I'm trying to stick with your books because you're going to go home and you're going to do these assignments that I'm leaving for you. That's what the purpose was in giving you half of 8.NS1 the first time, and that's kind of why we're going where we're going today, which is to 8.NS.1b, which is going to begin, as far as we're concerned, in your GoMath book. Every one of you gets when you come into my room. And what we've done so far is we've looked at expressing rational numbers as decimals on page 7 and expressing decimals as rational numbers on page 8. If I go a little fast, remember, you can always go back and look at this stuff again. It's not going to be a problem for you. This is always available to you on our wonderful Teams website. Mr. Gutierrez and I are working very hard to make sure that you have sources to get information from. All right. Don't forget videos to learn. There's other places to go to find out in case you don't get what I'm telling you. That's going to happen from time to time. So now we're going to be looking at finding square roots and cube roots on page 9. Square roots and cube roots on page 9. Now, having said that, let me say, I know you have calculators. You should be able to find a square root very easily. Just put the value in and press the button that looks like this. Okay? Now on the other side to that, we're talking cube roots. Now this means that I can take the value and multiply it times itself to get what I need to get. So basically what we're talking about is the square root of 4 equals 2. 2 times 2 equals 4. That's really all that means. So in other words, 2 squared equals 4. Both of those statements are telling you the same data and information. All right, so having said that, what we want to be sure that we understand is that cube roots are a little bit more strange. All right, and they look like this. They tell you that you want to be able to power it up to the third. So if I said to you that I want the cube root of a value like, for example, 27. 27. What I'm looking for is I'm looking for a value that I can say x times x times x equals 27. True dat? Of course true dat. That's what that 3 there means. Then I'm going to take 3 values, multiply them times each other, and get 27. Now, just to simplify things, don't we all know 3 to the third power equals 27? Now, you may not be really sharp on that. That's okay, because you can still do this by using the power of a calculator. But essentially what we're talking about is 3 times 3 times 3 equals 27. It's how you look at it that makes the difference. So in your book, they give you 2 examples to look at. And I think from this model in example 3, we got it covered, because what they've looked at here is they've looked at x squared equals 121. Well, if I square root 121 on a calculator, I'm going to find x equals 11. And I'll put that this is example 3. Okay? So, doesn't that mean x times x equals 121? Try that on your calculator. See if that's true. Are we good? All right, so now, so here we go. We're going to change things around just a little bit. And this is an important concept for you guys to catch on to. So I want to make sure that we touch on it. We're still on example 3 on page 9. All right? But this is B. If I don't write it the first time correctly, it's going to be hard to fix it because I still have to align my board. But example 3, D, gives us this to work with. X equals, excuse me, x squared equals, I knew I had that. I was missing something. X squared equals 16 divided by 69. 169. Now you might not recognize it too quickly, but if x squared equals 16 169ths, then I'm going to look for x by finding the square root of 16 169ths. Right? Now what I have to realize first is that whatever I come up with here has to be positive and negative. Because a negative times a negative is a positive. So I'm going to be looking for, excuse me, that's still got to go there. I'm looking for x times x equals 16 169ths. That goes right along with what I said on the first page here, and it's going to carry on that way just as well. Now, the easy way to understand this is to say, okay, I need the square root of 16 and the square root of 169. So we're saying now x squared equals the square root of 16 divided by the square root of 169. And when I come down here and I say x equals, I need to be able to say this answer is positive and negative. We'll understand that a little bit better when we go back and look at x times x, okay? So bear with me. What's the square root of 16? I think everyone in my 8th grade class should know what the square root of 16 is. And if not, what do? Put the number in and hit the square root button. Well, guess what happens when we do that with 169? And if you look in the example in the book, right here, it says 4/13. 4/13. And notice it says plus and minus because it's positive and negative. Now, how do I prove that? Well, that means 4/13 times 4/13 equals 16 169ths. Well, you know how to multiply a simple fraction. That's the easy thing. So what we're going to do is we're going to multiply across the top and multiply across the bottom. 13 times 13 is 169. 4 times 4 is 16. Easy peasy lemon squeezy. Now, try to keep the videos short, but we're going to move on to the next page because I got a couple of more minutes here I want to use so you don't have too many videos. After that, all that's there is more examples, but it does go to x to the 3rd power. So let's look at that. Now, the way they've done this in example C is 729 equals x to the third. Mathematically, that's not a great thing to say. Not a great thing to say. But that just means Mr. Kolesnick is going to write it the other way so that it's simple enough for you to be able to understand it by seeing it the same way all the time that I'm going to want to do it. What I need to do is I need to cube root x to the third to find the value of x. The cube root of x to the third equals x. That's how we're going to get to our solution. Now, having said that, that means I need the cube root for this problem of 729. So I need a value that's going to go x times x times x equals 729. Just like it says in example C. Alright? Example C right here. We're not going to do D, because I think you'll figure that out pretty quickly. And they've come up with 9 equals x, or x equals 9. And if that's true, then 9 times 9 times 9 equals 729. True or false? Check it on your computer, your calculator in your hands, whatever you're going to do for this. You can do the cube root with a calculator. I'm a happy camper, and you should be too. All right. So with that, I'm going to close this out. Well, when we get to C, we'll be on page 10, estimating irrational numbers. See you in class.